Hi, Sir Oliver. I am James from ESCS4. Welcome to my video presentation and our final project in CSC 172, Data Mining and Analysis. Apparently, wala pa naka-slideshow kaya kung ako ay maximize lang ako window, mupitok siya. On top of that, due to time constraints, we will not go through the specifics of each section, much of which is on paper. Without further ado, let's dive right in. Our prediction by multiple linear regression. Table of contents, introduction, related literature, methodology, results, and discussion. Introduction. New car prices have accelerated in recent ages as with many other consumer goods due to an ongoing chip shortage and increased raw material costs. In September 2022, the average price of a new vehicle in the US was up 6.3% year-over-year, according to figures from JD Power data analytics firm. This, along with soaring gasoline prices and rising interest rates, is making car ownership more onerous and slowing down auto sales, creating a supply crunch. The market for cars is a complex and multifaceted industry that plays a significant role in the global economy as one of its backbones. Understanding the factors that influence car prices and being able to accurately predict future car prices can have important implications for a wide range of stakeholders, including car manufacturers, dealerships, consumers, financial institutions, and policymakers. For car manufacturers and dealerships, they can optimize inventory and management and pricing strategies, leading to more efficient operations and increased profits. For consumers, they can budget for a purchase or negotiate a better price when buying a car. Financial institutions and investors can also benefit from car price prediction by using it to make more pragmatic investment and lending decisions. Policymakers and researchers may also be interested in car price prediction to understand trends and patterns in the market and identify potential areas for intervention or advice. They can advise the development of policies aimed at promoting more sustainable or affordable transportation options. Similarly, researchers may use car price prediction to study the factors that influence car prices and to identify opportunities for innovation or breakthroughs in the design and production of cars. Despite the importance of car price prediction, a high-interest research area that requires noticeable effort and knowledge of the field expert, predicting car prices can be a challenging task. This is due to the complexity of the market and the nature of its dependence on a variety of factors. In this scheme, the importance of car price prediction is explored, and some of the methods that have been developed for this purpose are discussed thereon. Related literature. The dataset contained the following car specifications: aspiration, which refers to the type of air intake system that an engine uses under normal atmospheric pressure; wheelbase, which is the horizontal distance between the centers of the front and rear wheels; curb weight, or the weight of a vehicle with all standard treatment but without any passengers or cargo; cylinder, or a chamber where the fuel gets combusted to generate power; bore-stroke ratio, which is the ratio between the dimensions of the engine cylinder bore diameter to its piston stroke length; compression ratio, which is the ratio between the volume of the cylinder and combustion chamber in an internal combustion engine at their maximum and minimum values; revolutions per minute, which is the number of times that an engine crankshaft makes a full rotation in 1 minute; drive wheel, which is a motor vehicle that transmits force and torque into a tractive force; miles per gallon, or the distance measured in miles that a car can travel per gallon of fuel; fuel injection system, or the components involved in transporting, metering, and mixing the fuel from the fuel tank to the combustion chamber; horsepower, the common unit of power, or the rate at which work is done; ID, price, length, width, height, engine, capacity and placement, fuel, doors, body construction, make, and model. Data mining, an interdisciplinary subfield of computer science, is the computational process of discovering patterns in large datasets involving methods at the intersection of artificial intelligence, machine learning, statistics, and database systems. Regression. Regression models are the mainstay of predictive analytics. The focus lies on establishing a mathematical equation as a model to represent the interactions between the different variables in consideration. Regression analysis. In statistics, regression analysis is a statistical method used to examine the relationships between variables. It includes various techniques for modeling and analyzing multiple variables, with a focus on the relationship between a dependent variable and one or more independent variables or predictors. Linear regression. Linear regression is a statistical method used to model the relationship between a scalar dependent variable y and one or more independent variable x. Assumptions. Linear regression models that use standard estimation techniques assume certain things about the predictor and response variables as well as their relationship. However, there are various ways to modify these assumptions, known as extensions, that allow for some or all of them to be relaxed or eliminated. First is with exogeneity. This refers to the assumption that the predictor variables in a statistical model can be treated as fixed values rather than random variables. This allows for the predictor variables to be free from measurement errors. That is typically common in regression models. So linearity in a statistical model refers to the assumption that the mean of the response variable is a linear combination of the predictor variables and the model parameters. Constant variance refers to the assumption that the variance errors in the response variable is the same regardless of the values of the predictor variables. So independent of errors refers to the assumption that the errors in the response variable are not correlated with each other. Lack of multicollinearity. This means that there is no strong correlation between the predictor variables in a statistical model. Least squares estimation. Ordinary least squares is the simplest and thus most common estimator. It is conceptually simple and computationally straightforward. The OLS method minimizes the sum of squared residuals and leads to a closed form expression for the estimated value of the unknown parameter beta. Scikit-learn is a state-of-the-art machine learning library for Python that is designed to accommodate a broad range of supervised and unsupervised learning algorithms for medium-scale data processing tasks. Related works. Kudaru used a machine learning technique to predict the price of used cars and compare the results obtained using 4 different methods: multiple linear regression, k-nearest neighbors, naive Bayes, and decision tree. Osgood et al. Attempted to investigate and establish linear regression in predicting the prices of used cars. Chen et al. Performed a comparative study of various models to identify the optimal used car price prediction model. Al et al. Also used random variance to predict used car prices in their research study. All three tried to develop a linear regression algorithm for the prediction task and found that class, year of manufacture, and kilometers were the most significant attributes that influenced the price of used cars. U3 and Safit3 analyzed the characteristics of a used car, such as the age of the car, its mileage, color, type, and transmission, in predicting the best selling price of a used car. Methodology. As the initial step in this research project, a dataset comprising 205 records of car prices and their corresponding features was obtained from Pagan. The dataset served as the foundation for the study and provided a wealth of information for the investigation of the factors that influence car prices. CSV file was read initially into a two-dimensional heterogeneous table, which is a data frame through pandas with column denominations or names from its first row and axis and data in axis rows. The rename function was applied to the cardinal column in the data frame to change its name to cardinal. The shape attribute of the data frame was used to obtain its dimensions. The info function was used to get a summary of the data frame. The describe method was used on a given dataset to generate descriptive statistics. The drop method was used to remove a specific column from the data frame, which is an access column that is the car ID. The string split method was applied to split the values in the cardinal column on the space character. The replace method was used to rectify typographical errors and abbreviations in the values of the cardinal column. A new column called bracket was created in the data frame to categorize the price of each car into one of three categories: economical, mid-range, or expensive, based on the specified price bids. The getDummies function from the pandas library was used to create a new data frame with dummy variables for the categorical features in the dataset. The train test split function was used to split the dataset into two separate data frames for training and testing. The fit transform method of a scalar object was used to scale the quantitative features in the train data frame. Feature selection. This is a process in machine learning and statistics where a subset of relevant features is selected for use in model construction. Given an ordinary least squares linear regression as an external estimator that assigns weights to features, scikit-learn's implementation of RFE strategy was used to select features by recursively considering smaller and smaller sets of features. Model train. Once the data has been prepared and the relevant features have been identified, the method of linear ordinary least squares regression was trained using the data. The model was trained until the VIF is less than 5 and the p-value is less than 0.05. This helped ensure that the model is not overfitted and that the relationships between the predictor variables and the response variable are statistically significant. In time, the p-values and covariance inflation factor of each feature in our final model is below a specified threshold if its p-value is less than 0.05, which this feature satisfies, and the variance inflation factor for these features is less than 5, which indicates the absence of multicollinearity between these relevant predictors. As per model evaluation, the model was evaluated using a separate testing set rather than just using the training set. The coefficient of determination, or R-squared, was used as a metric for evaluating the fit of a linear regression model. In addition to this metric, a scatterplot was also used to visually assess the fit of the model and identify the outliers or the trends within the graph. So results and discussion. A box and whisker plot for the distribution of quantitative continuous variable price. So what this graph is trying to convey is the 5-number summary of the variable price, that is the median, first quartile, IQRs, the maximum, the minimum, and the outliers. So it is skewed to the right. The distribution is skewed to the right, and these are the several reasons why the distribution of car prices might be skewed to the right. So purchasing power can also play a role in the positive skew of the distribution, since in general consumers may be more likely to purchase less expensive cars, which can also contribute to the right skew of the distribution. Luxury cars or high-end luxury cars tend to have higher prices, which can pull the overall distribution of car prices to the right. Older cars, as cars age, they tend to depreciate in value, which can lead to a higher concentration of lower-priced cars. This can cause the distribution of car prices to be skewed to the right. Market demand. Factors such as market demand and supply can affect car prices. If there is a high demand for certain types of cars, such as SUVs or sports cars, the prices of those types of cars may be higher, causing the distribution of car prices to be skewed to the right. Sales and discounts. Sales and discounts can also affect the distribution of car prices. For example, if a car dealership is offering a sale on a particular model, the price of that model may be lower than usual, which can cause the distribution of car prices to be skewed to the right. So here's a bar chart for car mix, and Toyota is the most favored brand. So here's a pairwise correspondence plot between quantitative variables in the data. So the positive correlation between car price and its curved weight, engine capacity, and horsepower in this figure suggests that this may contribute to the overall cost of a car. On the other hand, the fuel efficiency measured in miles per gallon of both city and highway will be more affordable or economically friendly than cars with worse fuel efficiency, as with this graph. So here's a box and whisker plot for qualitative variables relative to the criterion price. So there are several factors that can contribute to the higher price of cars with diesel fuel compared to cars with gas. Some of the possible reasons include production cost. Diesel engines tend to be more complex and expensive to manufacture than gasoline engines. Fuel efficiency. Diesel fuel is typically more energy dense than gasoline, which means that diesel engines can get more mileage from a given amount of fuel. As a result, diesel cars tend to be more fuel efficient than gas cars, which can make them more expensive to purchase. Performance. Diesel engines tend to be more powerful and have better torque than gasoline engines, which can make them more appealing to certain customers. However, this performance advantage can also contribute to higher prices for diesel cars. Emissions. Diesels tend to produce lower levels of carbon dioxide emissions than gasoline engines, which can make them more attractive to environmentally conscious consumers. However, the stricter emission standards for diesel engines can also drive up the price of diesel cars. Market demand. The demand for diesel cars may be lower than the demand for gas cars, which can lead to higher prices due to the law of supply and demand. So there are several factors that can contribute to the higher prices of cars with a rear engine location compared to cars with that of the front. Some of the possible reasons include production cost. Rear engine cars tend to be more complex and expensive to manufacture than front engine cars due to the additional engineering and design considerations required to balance the weight of the engine at the rear of the car. performance. Rear engine cars tend to have different weight distribution or better center of gravity and handling characteristics for improved traction and acceleration than front engine cars, which can make them more appealing to certain drivers. Moreover, the price of a car is proportional to the number of cylinders. Cars with OHCV engines are within an inflated price range. Doors do not affect car expenses to a certain degree. Rear-wheel drives are high-end. So, uh, here's a bar chart for car cylinders, fuels, and body constructions. So, four cylinders are um, there are four cylinders in the book of cars, and gas-fueled vehicles overwhelm diesel, and sedan is the most preferred automobile body style. So, so here's a bar chart for car makes against their average price. Jaguar, Buick, Porsche are the top three premium car brands. So here's a bar chart for car body construction versus their average price. So hardtop is the most expensive, followed by convertible, with hatchback being the most economical. So here's the heat map with pairwise correlation coefficients of columns. So it doesn't quite tell us a lot, but this scatter plots here tell us that the price of a car on its curve weight, engine capacity, fuel efficiency, and width have correlations. While the miles per gallon or fuel efficiency have a negative correlation with the price, the remaining features have a positive correlation with it, however. So assumptions. Here's the histogram of residuals. It follows a normal distribution, which more likely be a assumption fulfillment. So here's the predicted against actual y plot, which conveys that which conveys linearity and a satisfaction for the assumptions of linearity. So here's the for homoscedasticity. I used Bush-Hagen. More of this in the paper. So the null hypothesis of homoscedasticity will not be rejected if the p-value of Lagrange multiplier test is greater than an acceptable level of significance. If the p-value is greater than 0.05, since 3.55 is greater than 0.05, we will not reject the null hypothesis of homoscedasticity. Thus, another hypothesis fulfillment. Table 2 for no multicollinearity. So as evident here, the features have a variance inflation factor that is less than a predefined threshold, which is an indicator that these features are statistically significant among the presence of the other predictor variables, which is this. So, which is an assumption fulfillment that no multicollinearity between the predictor variables. So, no autocorrelation. So here's the Durbin-Watson test statistic is used. So a rule of thumb is that the DW test statistic values in the range of 1.5 to 2.5 are relatively normal and is not a cause of concern. So another hypothesis fulfillment. So in this study, the model's R-squared was 0.91, which indicates that the model fits the data well and explains a large proportion of the variance in the response variable, about 91%. So conclusion, car prices are an important factor for both buyers and sellers. Accurate price predictions can help buyers make informed judgments and can assist sellers in setting competitive prices. A multiple linear regression model was trained on this data, and its performance was evaluated using standard metrics. The results indicated that the model was able to make accurate price predictions with a 0.91 R-squared coefficient of determination. So recommendations: gather a large and diverse dataset. Use cross-validation to assess model performance. Consider using regularization techniques such as RAGE or lasso, etc. Evaluate model performance and interpret results. Use the model to make informed decisions and model deployment. Thank you, sir.